Okay, so final pieces of the puzzle. We have our agent defined, which is living in our cell, holding chemical, and it knows how to diffuse it out to its neighbors. We have the model defined, which has a space and a time, space of 50-50 grid, a time which is going to happen simultaneously, we've decided. And the last thing is to be able to visualize it and run it. Now you can do a lot with just the pieces we've defined so far. You could create models and run them. But if you want to see them, which is one of the huge benefits of agent-based modeling, we have to go create the server and a way to run the model. So let's go get those set up. So let's make a new file called the server. Okay, the server is going to bring in a lot of stuff from Mesa. So from Mesa, visualization, we're going to import the modular server. And from the Mesa visualization modules, we're going to import canvas grid. We're going to be able to draw stuff on the screen with this one, and I also need to talk about those user parameters. User settable parameter. And when I get to them, I'll back and refer to them again. I need my model. So from the model, import diffusion, and let's go start getting things set up here. Okay, so the big thing that we're going to have to make here is a server. The server is going to be equal to the modular server. And to make a modular server is going to take four things. First thing it takes is the name of the model class. Not parentheses, but just the name of it to say this is the class that is going to be part of this. We are going to put in a grid talking about how to visualize things. Let's call this the canvas element. Okay, we get to put in a name, chemical diffusion, and we get to create parameters for our model. Okay, so this name is what shows up here, chemical diffusion, when I start running the server. These parameters are going to be either just put in as numbers, so let's do that first. Let's go ahead and create these parameters. It is just going to be a dictionary, and it's going to be full of the height, 50, width. These are all the things that are going to get passed into diffusion. When I say go ahead and run the server and reset and do other things, it is going to call diffusion with these parameters. So height, 50, width, 50. Now there were other ones out there, right? Evaporate. There was diffusion, and there was the initial drop. Those numbers, I want to bring them in from sliders. I want to create these sliders on the screen. And so what I get to do here is use user settable parameter. So I'm going to make a user settable parameter based on a slider, and it's going to have a name, evaporation rate. Notice that's right up here, evaporation rate. I'm creating that, and then I'm going to set it to have a default value of 0.07. Notice it's set on that when I run the screen, 0.07, and my scale goes from 0.01 to 0.3, and my increments are in 1/100th. So those are the values I need to put in here. What is my initial value? What number is the lower end? What number is the higher end? And then what is my increment? So essentially, I have to do that for every single one of these. You are going to be a user settable parameter for diffusion. It needs to say diffusion rate going from 0 to 1 and a scale of 1/10. So you are going to be diffusion rate. Let's initialize you to 0.3, and you're going to go from 0 up to 1 at 1/10. And I need a comma here to make everybody happy. And this one is going to be my initial drop, again in English. So 500 is my initial value. I'm going to have it scale from 100 to 1,000, and my divisions are going to be in 50. Initial drop at 500, but I can change them, and they are gradated at points of differences for 50. Okay, so that's going to create these sliders. You want to have your model based on user input on the server, then you get to create these user settable parameters. They're really cool. Okay, so the other piece that's down here we haven't defined is the canvas element. And this is where the canvas grid comes into play. So we've used the module server, the user settable parameter, and now the canvas grid. The canvas grid needs to know, how am I going to portray each of those cells? This is going to be a dictionary, and I'll define it here in a second, but we need to say I'm going to have grid spaces 50-50, and on the screen it's going to take 500 pixels by 500 pixels. So this is the number of cells you have, and this is the size in terms of pixels on the screen. Okay, so let's build up the diffusion portrayal. This is our dictionary of what things are going to look like. Diffusion portrayal is going to be based on agent, and then it's going to bring in that agent, and we are going to, if the agent is none, if there's nobody here, well then I don't portray anything. Otherwise, let's go ahead and start making my dictionary. My shape is going to be a rectangle. My width is going to be the full rectangle. My height is going to be the full height of the rectangle. Am I a filled rectangle? Yes, I'm going to say true. And what layer should I be drawn on? Now this is more important for things that are multi-agents running around the screen. We'll get to that later in a later video, but this one says I am just going to be at layer 0. Notice that's why layer 0 shows up when you scroll over here, because you can look at the different things and you can see the different numbers that are in there in different ways. Layer 0 is what everything is at. Okay, so this is great. I have a shape, width, height, it's filled, it's at layer 0, but I don't have a color yet. Okay. This is going to be dynamic, and it's going to be based on the amount of chemical that is there. Now this is where this model gets a little tricky. It would be really cool if I could just say the color is equal to like some hex code. FF0000. So that would be cool to make this a red square, and this would make every square up there red. But I want it to be somewhat based on this, and so what I'm going to do is I'm going to have to calculate how much red should be there. And then I am going to be changing the scale of everything else around it. So let's go ahead and do that here. I'm going to do some Python things here. %o to x, %o to x, which is going to let me add in through formatting two numbers here. Okay, so how much red should be there? Notice that I am going to have things be red, but then it's going to be fading to white. I want it to fade to white. And so if there's a lot of red, I want these values to be, there's a lot of red, and so this is going to be 0 over here. So F00, 0. If there's not much red, then I want this to be 255. So if red is a 1 or 0, then I should get FF, 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 which is going to be all white for my color. So how can I calculate the red value? The red is going to be an integer value based on the log norm of the agent amount and the agent model lower bound and the agent model init drop. And I'm going to multiply that by 255. Okay, Lognorm, what is that? It is a way to scale things nicely. So in terms of our diffusion, things are decaying exponentially as things are diffused and evaporated. That is hard to visualize on a linear scale. And so I can't just say, what is the amount, and put that as a number between 0 and 255. I want to take the amount and scale it logarithmically. And I'm going to scale it between two numbers, the lower bound of the model and the initial drop of the model. So if it's 500 and 0.01, those are going to be my lower bound and my upper bound for my amount. So the only last thing I have to do here to get everything working is to write that function. Here's the log norm of a value given a lower and upper bound. Let's go have the value make sure it's within the bounds. So I'm going to minimize the value and lower. So if the lower bound is less than my value becomes the lower bound. Again, if the value is greater than the upper bound, the value becomes the upper bound. So now I make sure that my value is in bounds. That's great, because then the rest of my math can just be, let's calculate the log of the lower value. Oh, that reminds me, I need to import math. And then I can say upper log equals math.log of the upper value, and then value log equals math.log of the value. So I have my three numbers now, value, lower, and upper, all converted into log. And now I can just scale it in the log values. So return the value log minus lower log divided by upper log minus lower log. So I have my linear scaling in logarithmic space. Okay, so you put all those pieces together, you have your agents, your model, and your server. One more thing you need is probably out here to create a new file called run.py. Okay, what run.py needs to do, you need to say from this module that I've been creating, Diffusion, from the server file I just wrote, import server. Now look, I defined that down here. Server is this. So I'm going to import that in here, and then server launch. Okay, that's it. If I have this, then I should be able to go out there and start to run my model and calculate and visualize what's happening. So I have agents, I have a model, and then I have a server to visualize and put everything together. That is making my chemical diffusion model work.